Good evening, class. Tonight we are working on Module 5, Lesson 15, and our objective is to find common units or number of units to compare two fractions. So it's very similar to what we were doing last night, just taking it to the next level. For this first problem, I have 3/4 and I have 4/5. I can't turn these fourths. There's nothing I can multiply 4 by to make it fifths, and there's nothing I can multiply 3 by to make it 4. So it's a little more challenging than the problems I did yesterday. I can think about where these are related to 1/2, and I know that 3/4 is greater than 1/2, and 4/5, well, that's also greater than 1/2. So using that benchmark fraction of 1/2 doesn't really help me in this case. So I need a new way to be able to compare these fractions. We need to find a denominator that these fractions would have in common, and we are going to use area models to help us do that. So the first thing I'm going to do is draw two pictures of what these fractions look like. So this fraction I'm going to turn into 3/4. So here are my fourths. I'm going to shade in 3 of those. And you'll notice that I drew my bars vertically, up and down. For the other one, I'm going to create my tape diagram for 4/5, but instead of drawing them vertically, I'm going to make my fifths going horizontally, and I am going to shade in 1, 2, 3, 4 of them. What I'm going to do is take the fifth, so if I look at this as an area model, I've got 4 along the side, I've got 5 along my width. I'm going to draw these 4 vertical lines that I put on this tape diagram. I'm going to draw those 4 vertical lines over here. So now basically all I did was I took my fifths, I multiplied it by 4, and I'm making an equivalent fraction. Now I have 20 pieces all together, and I can count how many of them are shaded. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 are shaded. That's what it shows in my new area model. Well, that's also what it shows with my multiplication. I took my fifths and I multiplied it by 4 rows, or 4 vertical rows, to get 20 pieces. I also took my 4 horizontal shaded pieces and multiplied it by the 4, because we remember that rule to find equal fractions. Whatever I do to the top, I have to do to the bottom. So I know that 16/20 is equal to 4/5. Now I'm going to do the same thing over on this other side. For this area model, my 3/4, I'm going to draw the 5 horizontal rows. So I'm basically just multiplying this 4 by 5, and whatever I do to the bottom, I have to do to the top. So now it's 3 times 5. Well, now my equivalent fraction is 15/20. Now that I have found common units, I have found equivalent fractions and changed them so that they have the same denominator. Now I'm looking at 20ths. This one has 15/20. This one has 16/20. So I know that that is the greater fraction. So 3/4 is less than 4/5. I'm going to walk through those steps one more time. I'm going to draw my 2/3. 1, 2, and I'm also going to draw my 3/5, but I'm going to make my fifths horizontal, and I'm going to shade in 1, 2, 3 of them. And since this has 3 on this side, this has 5, I'm going to break them up so that this also has 5 on the side and that this also has 3. So I'm making my 3 rows here, and on here I'm making my 5 horizontal rows. So now the area of both of these is the same. I'm multiplying my fifths by 3, and I'm multiplying my thirds by 5 to get 2 new equal fractions. So my question for you is, what are the new equivalent fractions, and then which of these fractions is greater, 2/3 or 3/5. This problem I'm going to use a different strategy because when I look at these fractions, 5/3 and 7/4, I realize that they are improper fractions. They're both greater than 1/2. My numerator is larger than my denominator for both of them. So the first thing I want to do is decompose them so that I have 1/2 and then whatever pieces are left over. So 5/3, I'm going to decompose that as 3/3 plus 2/3. So that's my 1/2. The 2/3 is what I have left over. I'm going to do the same thing over here with my 7/4. I'm going to decompose that so I have 1/2, 4/4, and then I have 3/4 left over. So now when I'm comparing, I don't have to look at the 1/2. I know that these parts are equal to each other. The parts that I'm comparing are 2/3 to 3/4. And I know that 2/3 is 1/3 away from being 1/2. That would equal 3/3. My 3/4 is only 1/4 away from being 1/2. So which of these numbers is closer to 1/2, 3/4 or 2/3? They're both 1 unit away from 1/2, but 1/3 is a much bigger piece than 1/4 is. So 1/3 is closer to 1/2. So I know that 7/4 is going to be greater than 5/3. I could also draw tape diagrams of my thirds and fourths to see that as well. I can compare my 2/3 and my 3/4. So my 3/4 would go all the way up to there. My 2/3 would only go to there. So you can see 1/3 away from 1/2 is a bigger piece than that 1/4, which is why these 3/4 is a bigger number. Time for you to try it. First of all, decompose these fractions so that you have 1/2 and then the amount that's left over. And then just compare that amount that's left over to determine which of these fractions is greater. One more for us to find common units to compare. Here on this fraction, I have fifths and I have fourths. Ask yourself, is there some way I can find an equivalent fraction so that they would be the same? Go back and watch the beginning of this video if you need to remember how to draw those area models to find the equivalent fraction. Where I've got my fifths this way, I've got my fourths this way. How can we overlap those to get a new common denominator and then compare these fractions? When we are using that area model, we're basically just multiplying one denominator by the other. So 3/5 and 8/12. I'm going to multiply my fifths by the 12ths, and then I'm going to multiply my 12ths by the fifths in order to get a new common denominator and create equivalent fractions. And remember that rule, whatever you do to the bottom, you have to do to the top. So what are my new equivalent fractions? And then which of these is greater? Is 3/5 greater than, less than, or equal to 8/12? That is it for this evening. I know it seems very complex, so please bring your questions back to class where we will continue working on it. Have a great night.